Today we are here in the shop because I have an upgrade that I want to make on my Bridgeport. When I got it, I rebuilt the head completely and I changed all the bearings. There was one issue that I found with this head. The spindle in this head is bent. That's the problem I'm trying to fix today. So what I did is I found a replacement spindle. I don't know how good the quality of that spindle is, but we're gonna see. We're gonna check it out today. We're gonna see if it makes any improvements. One of the issues that I have with the spindle in the condition in which it is right now, that when you run it, there is noise coming from it. Let me give you a demo of the noise that the head makes when it's not engaged, so you can hear the noise from the motor, the belts, and all the drive unit on the top. And then we will engage the high speed so you can hear the noise that the spindle makes when it turns. So this, let me see if I can get the microphone a little bit closer. This is the sound that the head makes without the spindle engaged. As you can see, this is free right now. We can go up with the speed. It sounds great. There's nothing wrong with it. Everything is running just fine. The problem starts when we engage the spindle, because the shaft is bent. And because of the shaft being bent, it moves around and it makes a bad noise. Let's do that. Let's turn it on and I'll show you what I mean. I'm gonna put this now in high speed now. This is the high speed gear. Let's close the chuck, just make sure we don't mess up anything. So I'm going to turn it on now, and I want you to notice the difference in the sound that it makes right now. So right now it's decent. It depends on which teeth you engage on the drive unit, but you already can tell. Let me see if I can show you. Do you hear the noise that it's making right now? Now, the noise will change as I move the spindle up and down. When I move the quill, sorry. Now the noise you hear will change based on which teeth we engage, so I'm gonna try to engage it in a different position because sometimes it's worse and sometimes it's better. You can definitely tell now it's a little bit more noisy than before. So it's probably fine. You could run this as long as you want. I see no problems with the finish right now. Probably could use a little bit of help because again this vibration transfers to the tool. So, but we'll see. So in the next steps that I'm going to follow today, we're going to remove it. It's a very simple process, by the way. There is just a ring that we need to remove from the bottom of the quill, and then we just need to push down the shaft where the bearings are. It's a very simple process to do. We're going to have to tilt the head a little bit so we can get clearance. Maybe I'll move it forward a little bit so it's a little bit easier to operate. And once that is done, we can just push it down and we'll inspect, see if there is anything wrong, since I actually replaced the bearings in here and make sure everything is still fine. And then if everything looks good, we can go ahead and we can throw in the new spindle, see if it makes any difference, and we can see if the machine works better. One thing I might end up doing is I might get the bearings that I have right now on this spindle. Those are original Timken and they are sealed, whereas the new spindle that I got has a known brand, unknown quality bearings. They are not shielded. They don't have the rubber seals. They're open, so I don't even know how good the quality of the grease is. But you know, as a first test, we just can go ahead and take the whole assembly, replace everything, see how things work, see if this noise goes away, because I might be wrong. Maybe the noise is coming from somewhere else. If everything works fine, we're going to take it off again, change the bearings, and finish up the work with all the parts in place. All right, so now we should have enough clearance. We're gonna undo this ring on the bottom, and we're gonna, well, I'll probably remove the chuck too, because it doesn't need to be there, of course. But let's go with step one, which is moving that ring, and then we can try to push down the spindle, see how things look like. There we go. Put it back here. Now let's see how bad it is. This ring. It's hard to grab on this thing. That's the only problem. This Knapex worked out great to undo the ring on the bottom. Now let's see how tough it is to get the spindle out. Okay, so here's your ring. Has a labyrinth inside, you can see that, to protect the spindle a little bit from all the impurities that might come through the machining. Yeah, this spindle is in great shape. The only problem is that it has the spline is bent slightly, but it's bent. So how do we pull this out now? A good question. Make sure you put a hand underneath, because this might actually drop out fairly quickly. Of course, it's not long enough. Small piece of aluminum. That's perfect. Okay, let's keep going. We're almost there. A few more blows and this should get out. There we go. Okay. That's how easy it is to pull off the spindle on a Bridgeport. I think it's a good engineering approach. Okay, so let's get the camera out here. All right, you should see something. So here's the old spindle. I'll show you the run out on the lathe, but let's first compare with the new spindle, see how bad it is. This is the new one, and that's the old one. So they changed a few things. First of all, this is lower. I don't think that's a problem for us. It uses a snap ring rather than using this nut over here. And here, the assembly had a spacer in between, and this spacer was keeping in place the top bearing, the bottom bearing, and applying the pressure for the preloading. The new geometry instead has the nut, which only compresses these two bearings, which are the two bearings that get preloaded and work close to the spindle. Everything else, like dimension-wise, I think we're in good shape. It should be just a one-to-one replacement. They will serve the same purpose. Now again, these bearings are. Oh, wait a second. There is a seal in there. I don't know how much I trust that. I don't see a seal on the bottom. So these came pre-lubricated. These are lubricated for life. They're a little bit more expensive, and those are the Timken ones that I replaced last or 2 years ago. This came with a new shaft. So I think we can give it a shot and see how these bearings do. You know, they don't sound horrible. I don't trust them as much as I trust these. Unknown origin, whatever. But everything else seems decent. So yeah, there might be some cleanup to do here on this shaft. The splines are not as clean and deburred as they should, but they're not terrible either. They're not cutting my hands, so it's not too bad. All right, let's go ahead and just throw this in. The grease should be fine in here. Again, those bearings, they don't sound terrible, but they are unknown. So for this first test, I think they're gonna be fine. One thing I'm gonna do before I try to shove this in is I'm gonna try to line up this spacer with the bearings, so we don't have to fight it when we have the spindle on the machine. This should be just a slightly undersized ring. Should be easy to push it in. Yeah, I think I'm gonna keep the original one, the original assembly all together, and I'm not gonna touch anything on this guy. We might even see if we can straighten this up. That might be something we can try to do. because I would like to keep this thing original. Okay, there is no set screw for the R8 collet lock, which is fine. Let's go ahead and put this on the machine. We'll see how this works. Okay, so let's see where we are. Let's move this around. Bring you back to the. Is that good enough? You can probably see something from there, right? Okay, so what I'm gonna do is now, we don't need this, the pull anymore. I can put this back, hopefully. There we go. Let me pull this out all the way so we don't have it in the way. Put this on the side. Now, we just hammered this up the same way it came out. We'll go in. And then we'll tighten the nut on the bottom. Doesn't need to be super tight, but needs to be tight enough so it doesn't get loose. Okay, what's going on here? I feel something. There we go. All right. Yeah, see how easy this goes up? Too easy. There we go. It's all the way up. Now we'll finish tightening the nut. Hopefully the labyrinth will still work fine. There's gonna be no interference. Let's give it a quick clean because there's some shit in here. There we go. So there is a light coat of grease, which is good. I'm gonna leave the grease I had in there before. And I normally don't even lock this ring in place. There is a set screw that you can tighten for this, but again, I never got it came loose on me, so I think we're fine. Now, one thing that always disturbs me is that this guy should not be touching. I think what's going on here is that either we're missing some spacers or this spacer ring on the bottom, it's too shallow, because this needs to tighten on the spindle cartridge. If it doesn't tighten on the spindle cartridge, what happens is that you might have this entire assembly floating up and down when you apply pressure when you come back. So we're gonna have to come back to that, because I'm pretty sure there is something wrong with it. But for now, we're gonna just assess if this made any difference in the way the spindle sounds. Because if it didn't, I might as well go back to the other spindle, which has the original bearings and all the original parts, which I honestly would not mind keeping as original as possible for this machine. We should be good to go now. Moment of truth. Let me get you closer. Oh, that's why. Okay. Got our spindle. Right now we are in the neutral. Let's make sure it works fine in neutral. All right. Let's go now to the high gear. Right away. It's fully engaged. I don't know, sounds better, feels a little bit better, but it's not perfect. So what to do? I don't know. Let's try more. So what we can try to do is engage it on a different. I mean, it's not bad. decent. Now, this is not an original spindle, as you might have understood already. I got it on Amazon. Let me put this in place, and let's put the tool changer in place. Let's give it a shot, right? So we can do a full test. All right, let's set this guy up for 1500 RPM. 1400 should be plenty. Now, yeah, you hear it, see? Something else is being noisy right now. Feed is unknown. I don't know what the feed is, but it seems good enough. Okay, that's 25. I'm gonna even engage the brake on the y-axis. Okay. Nice. It was conventional cutting. I'm gonna go back, climb cut without giving any more cutting depth. It's just a spring pass. It's taking a wee bit of material, but I think it's pretty much spot on. I'm using an old end mill. I know it's not perfect, but I can't complain about the finish. I think it's pretty good. Okay. Yeah, there is absolutely no heating of the piece, so the cut was good. Chips were coming out white, so they were not even heating up, which is good. And this finish is beautiful. I think we have an improvement compared to the other spindle. I don't have anything to compare right now, but it feels smoother. I'm gonna try to do the same thing, side milling, but I'm gonna use the y-axis just to do a further test. Okay, let me set it up now. I know it's the same, but I know what the finish looked like when I was side milling before, and I think it makes sense for me to see, or at least compare, apples to apples. All right, let's get rid of the old parallel here. Give it a quick clean. Put the tall parallels in place. Of course, I need to clean them as well. And we need to clean also whatever is in here. There we go. A little rag to clean it. things nicely. Oh, we're gonna check run out as well, but as far as I can tell, if you judge by the finish, I know this is only 2-fluter, so I might be biased by that. We're gonna check the run out with an indicator, just to make sure that things are looking good. Want to check how well this taper has been ground on the new spindle. It feels great, and this spindle was extremely cheap, let me tell you that. Came with the bearings already. I think it was about $200 on Amazon. There's cheaper options on eBay, but I don't know about shipping, so I went for the easy option. All right, so this is the finish I was getting before. Okay, this was side mill cut with the other spindle, same tool, most likely. So it's hard to judge. This is pretty good already. I mean, I don't see any defects or any unevenness in here. There might be a little bit of background noise, could be due to the ways, because they're not super tight right now, so there might be a little bit of side motion on the dovetail. The gibs are not super tight, that's what I mean. But we'll see if there is any difference. Okay. Let's bring this guy down. Set the height. Something like that. So I don't have any power feed on the y-axis. I'm going to be feeding it by hand, but I'll try to be, whoops. I'll try to be consistent as much as a human can be. Well, there goes nothing. Again, I'll give it about 25 thou depth of cut, engage the brake. It feels nice. I don't know, maybe it's just psychological, but it feels better than the other spindle. It feels smoother. Tool is doing a great job, even though it's not new, but it's working well. All right. I mean, if anything, it's slightly better than the other one. It's hard to tell visually. It looks very good to me. I think it's at least on par with the other one. Okay, 25 thousandths. Probably just had to go a little bit faster with the feed. I'm feeding manually now. I can already tell the surface finish is way better. Yeah, no, this is perfect. Okay. I don't know how close you can see that, but I call this good. I think the spindle is fine. That's a success.